This is a milling machine. The various parts of milling machine are there. First one, base. Base. It carries the complete unit of the machine. Next one, column. It is a supportive frame. Next one, elevative screws. These two screws are elevative screws. Okay. Next one, knee. This part is knee. Next one, saddle. Okay. Next one, table. This one is spindle. This is a arbor shaft. This one, rocker arm. This one, indexing plate. And finally, this one is a cutter, milling cutter, multi-point milling cutter. Now, I will fix this specimen doing a spur gear operation. You have to fix like this, both end tighten. Here and tighten the knob. Understood? Okay, this is blank, cast iron blank. This complete unit is dog clutch. Clear? Okay, after fixing specimen, we have to go for calculation part. So, we are doing now spur gear operation. Spur gear operation. Okay. The page number 40. The aim of the experiment is to do the spur gear cutting operation on the given blank. Material is given already, cast iron blank. Okay. Tools are used: milling cutter, lathe dog, vernier caliper, long steel rule, brush and indexing plate. Clear? So, you just turn the page number 24. Get one example formula. Example, calculate the following cut of spur gear. Number of teeth is 28 and teeth using gear cutter is modulo is 2 mm and everything you have to calculate, okay, in the given, okay, in exam also. So, first of all, the number of teeth n is 27. Next, modulo m is 2 mm. Clear? Okay. Next, in page number 39, in that spur gear dimension for 14.5 pressure angle. So, angle is the given, pressure angle 14.5 degree. Okay. And next, the table, in that first one, symbol. Next one, tooth element. Next one, cutter in DP. Its formula is inch. Next one, cutter in modulo. Its formula is mm. Okay, you have to calculate all tooth elements. Okay, first one you go by one. And before you just check the modulo. Modulo is 2 mm. So they given only modulo. Cutter is in modulo form. Or they will give DP is 2 mm. So you have to refer cutter in DP format. Now here cutter in modulo format. So you have to refer only modulo column. Clear? Okay. In first one, circular pitch. Tooth element is circular pitch. In the formula is CP. What is the formula? You refer only modulo column. So cutter is in modulo mm. So formula is pi into m. Pi value you know 3.142 into m value is m is 2. Modulo is 2. Pi into 2. That's some answer. Next one, DP. Diametrical pitch. Formula is 1 by m. Next one, modulo. M is write directly 2. Next one, addendum. Formula is m. Dedendum. Formula is 1.157 into m. Tooth depth. Formula. Total division. Depth in division. Formula 2.157 m divided by LC. Least count. You just turn the page number 40. In that, given dp is unitless, m is inches or mm. Least count of machine 2 is 1 by 1200 or 0.02 mm, and machine 1 is 1 by 1000 mm, 0.025 mm. We are using only machine 1, so least count is 0.025 mm. Clear? Next step, sir. Pitch circle dia. Formula is n into m. N already given. Number of teeth is 27. M is modulo. Next one, width of the gear. Formula is same. So you have to refer here cutter in dp. So inch formulas. So 2 cp to 4 cp range. Next one, cutter number. Here also same. So same means you have to refer table. So in just next page 40. In this one table is there. Cutter number and range of the teeth. So our number of teeth is 27. So you just check here 27. So 27 to 34. Cutter number is 4. Suppose our number of teeth is 21. They already given. Okay, number of teeth 27, 21, whatever. Okay, so 21. In this 21 to 26, cutter number is 5. Clear now? Suppose they will give cutter number is 18. 18 to 20, 70, 20, cutter number is 6. Clear? Okay, next you one by one calculate. Next one, indexing plate. So indexing plate formula is indexing plate worm and worm wheel ratio divided by n. Same means worm and worm wheel ratio means formula is I is equal to 40 by n. I is equal to 40 by n means 40 means the indexing plate you have to turn 40 times. Workpiece also rotated complete one rotation. So if you rotate indexing plate 40 times, one of the indexing plate you will turn this one 40 times. Workpiece is turn one complete rotation. Here now you substitute. I is equal to 40 by number of teeth is 27. So you have to substitute this one fraction form. So 27, 1, balance 13. So it means one full rotation of the indexing plate and 12 holes in 28 hole circle of the indexing plate. Clear? One complete rotation of the indexing plate, 27 hole, here 27 holes, and 13th division of the indexing plate. Okay. In some holes are available in indexing plate. In page number 40, whole circle is available in indexing plate. One side is 43, 29, 33, 21, 27, 18, 17, 13. And other side is balance 51, 49 something holes. So, or a number of 27 hole is available. Here 27 number of hole is available. So, you have to directly substitute. 27, 1 the 27, balance is 13. You have to fix this value in that indexing plate. Clear? I'll show how to fix this one. Okay. Okay, sometime they will give number of teeth is 21. So just check the 21 hole is available in this plate. 21 hole is available here. Okay, sometime they will go 18. 18 is available. And sometime they will go number of teeth is 24. 24 is not available. So you have to this one convert into fraction form. How to convert? Either you multiply or subtract or divided, whatever. So formula is 40 by n means 24. You have to multiply by 3. Multiply by 3, it is 24 3 is a 72, 43 is a 120. So 72 is available? No. Again you divided by this value, divided by 4. 72 4 is a 72 divided by 4, 18. 124, how much? 30. Now 18 is available. Yeah, 18 is available. So here 18 is available. So 18 and balance still 30. 18, 18. 18 ones are 18. Balance is how much? 12. Clear? Okay. Suppose your value is here 36. So now 18 is available. 18. 2 rotation. 2s are 36. Balance is no here 0. 2 complete rotation only. Clear? Okay. Now you have to set the operation in here indexing plate. So here some holes are available. I already told you 13, 17, 18, 27, 21. So our number of hole is 27. So you loosen this pin and slowly you have to turn clockwise direction. Okay. Okay, you have to set here 27 number of teeth. So loosen this one and tight. You have to accurately set using pin. Now see 27 number of teeth is I set here. Clear? Then you have to pin. This one is sector arm. So this is only reference for you, sector arm. So don't concentrate more here. Okay. Next you have to fix your job properly. Already I fixed it. And here 27 number of hole I have fixed here. Next steps is here 2 knobs are there. One knob is initial setup of the milling cutter and next one is bed momentum, height and bed should be moved up and down movement. Clear? So using this knob, first you have to reduce the down the bed portion and rotate this handle. You have to rotate this handle clockwise direction. Clear, right? You have to turn clockwise direction. Okay. Next, again, you have to rotate this knob. Just here, you have to rotate. Just here, touch the specimen in a milling cutter. See, how it is touch or not? Not touch. See. Okay. Oh, now it is touch. Once touch, remove the knob. Okay. Next, in your that calculation part, in a depth in division, you have to some value is there. You get some value 160 or 150 depth in division. You have to set that value in here knob. First you set 0 here. So set 0. Both sides are 0. Set 0. Then you rotate till how much? 160 or 170 value. You have to turn till that much. So one complete rotation 100, 20, 30, 40, 50, 60 like this. Okay. Turn this one like this till 170. See now it is 165, 170 till. Okay. One complete rotation and 70 division. Next steps is blank is here 0. Switch on the machine using starter. I'll switch on machine. Now here power is supplied to motor. It's connected to spindle. Spindle is rotated. Spindle is connected to arbor shaft. Arbor shaft is rotated. Milling cutter is located on the arbor shaft. So milling cutter is here rotated. The two types of millings are there. One is up milling, another one is down milling. When the cutter is rotated opposite direction to the workpiece, it's called as up milling. When cutter is rotated same direction to the workpiece is called as down milling. So if you are rotated here same direction to the that cutter is called as down milling. Okay. Next step is you have to rotate this handle slowly in clockwise direction. Where you are using now you are doing only here spur gear operations, not helical gear. So you have to rotate only clockwise direction. Slowly you have to rotate clockwise direction. Once they touch, see, now it is removing the metal from the workpieces. So it is a milling is a metal removing from the workpieces. So now we are using only one job operation, sir. So this is multi-point cutter. So you have to use here 2 or 3 more jobs in these arbor shafts. Clear? So if you give means more depth, what happening? So depth of the size will be here increases. Slowly you have to turn clockwise direction. Understood now? Okay. Simple experiment. So everything will be do here machining only. Okay. Once you finish, take back this one. Okay. Take back this one. Okay. Now we are observe this teeth. So I'll give depth only 70 depth. So this teeth sizes. Next steps is how to remove, how to rotate this cutter. Here only indexing plate. So calculation is there. Our number of teeth is 27. One complete rotation and 13th division. 27 means in this 27 holes are there. First one, this is 0. 1, 2, 3, 4 like this till 27 here. So this is sector arm you have to use for your references 27. You have to loosen this one or rotate clockwise direction. One complete rotation means one rotation and 13 division. Just note down the hole sizes. 2, 3, here 3 hole. 4, 6, 7, 8, 9, 10, 11, 12. Here 13. You have to pin this one. Accurate hole. Okay. And tap. Next again you have to rotate clockwise direction. See there. Now we are doing next teeth operation. Clear? Okay. If you one hole here mistake, the distance will be vary. Okay. Now I finish second hole. And here once you set this depth, you not again rotate this one, okay. And here indexing plate, if you one hole make mistakes, say your distance is varying. Clear, right? Next steps is again pull down, pull up. Means till here to complete one rotation, till here to here 27, one rotation. And balance is how much? 13 division. You note down till here to 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13 till here. So till here one rotation. Again tap this one. Tap to the hole. And next again rotate clockwise direction. Come slowly in clockwise direction. Clear, right? Now see. Now we are observe the teeth of the spur gear operations. You have to do this continuously till full blank. So you have to make here. So already they told the number of teeth is 27. You have to make this blank 27 number of teeth. Clear, right?